Thank you all for joining this session. So today we're going to discuss about ventilation. We have already discussed particulate matter, carbon dioxide, monoxide, ozone, formaldehyde, nitrogen dioxide, and radon. And let's see what we have prepared for ventilation. Ventilation. Okay. As I always say, if you have any comments, feel free to interrupt me, or you can also raise your hand. But please try to keep your questions short and sweet, just in case we have more people that they would like to share their opinion. Okay. So during the survey that we conducted, I asked members some key questions in order to understand a little bit better their position around ventilation. One of the questions that I asked was how important is indoor air quality in buildings, and of course, that's good news. Everyone agreed that it was like the maximum number that we could give, with 5 out of 5. Then I ask how important is energy conservation in buildings. And again, the majority of people say that this is also very important. But in some other cases, people were a little bit more flexible and they suggested like it's like 3 out of 5 or 4 out of 5, which indicates that in some cases we have to consider more the air quality rather than energy. And the same thing reflects in the following question, where I asked in different environments, which of those parameters it's more important, indoor air quality, energy, or like 50-50. So as you can see for schools, now no one is talking about energy there. Like it was for everyone very important to have indoor air quality. And some people also answered like 50-50. For commercial spaces, then they start talking about energy, again, followed by indoor air quality, but the majority agreed on 50-50, like we have to find an equilibrium between those two. In retail spaces, the situation is a bit similar, but now energy is a bit higher and indoor air quality is at the same level, which agrees as well with the 50-50 parameter that we discussed. In residences, so houses, condos, etc., again, indoor air quality is the most important thing, but also we have to see about how we can manage having good air quality, but not breaking a bank. For hotels, surprisingly, I didn't see anyone talking about energy. Again, we have a tie between indoor air quality and like energy, 50-50. Hospitals, again, I think they share the same value like schools. We have population that they need excellent air quality, and for this reason, the priority of giving the building with good air is substantial here. And finally, in restaurants and cafes, I think they share the same opinion as a commercial space. I don't know if someone has any comment around those results, if they would like to say something else. Okay, I will continue. So then I asked members what are some common strategies to increase air changes per hour in buildings without having a big impact on energy. And those were some of the comments. Some of the members, as you know, are coming from the industry, so they will recommend their solutions. Again, if they are connected, I'm not sure. I'm more than happy for you guys to share your comments instead of me reading them one by one. But in most cases, we can see by having some kind of a controlled ventilating system, using energy recovering ventilation. It's another addiction on bringing more air indoors, but also conserving some of the heat inside the building, right? Someone is talking about a dual path filter, the use of a high filtration with MERV 13, only in particles are detectable by PMC sensors, and MERV 10 or lower otherwise. This could help to balance and reduce energy impact, also balanced outdoor intake vs internal recirculation based on sensor data, CO2 and other chemicals. And I assume also in some cases we have seen lately that people are using UV lamps in order to sterilize the air and be able to avoid losing heat by introducing cool or cold air from the outside air. Some people are saying that smart air quality sensors can adapt in buildings as they can calculate based on CO2 levels. For example, the need for air, for outdoor air in the indoor space. Someone else say that central air handling units and heat exchangers, which is the same thing. Another comment, there is a third way that improves air quality and reduces energy in air purification by reducing the pollutants inside the buildings. Outside air requirements for the same indoor air or filtration requirements are reduced. In both cases, reducing annual HVAC energy consumption by 30-50% for fixed flow rates and up to 70% for dynamic flow rates. This is called equivalent airflow. Another common ventilation has the sole purpose of reducing pollutants in the indoor air of a building. Until a few years ago, only two strategies were applied to improve indoor air. Either improve filtration, which increases pressure drop and consumption, or increase hourly renewals, which increase fan work and consumption. And finally, the use of pollution dampers or air purification that do not produce pollutant byproducts like radicals and oxygen-free radicals or ozone in some cases. I don't know if someone wants to add something else around those comments or maybe something completely different. No? Okay. So the next question was, what are some common strategies for increasing air exchanges in buildings without, oh, sorry, this is, oh, more answers, the same thing. So some other answers are that the HVAC unit is not designed for indoor air quality. Well, this is true on my experience as well for older buildings. It is designed for adding and removing heat, which they say the HVAC unit can support indoor air quality by passing the 52.2. I am assuming they're referring to the ASHRAE seals test. So the MERV filters used, we deliver the required MERV value. Some HVAC units can increase MERV values by just replacing the motor to the new fan curve, and energy is not an issue to the increase of pressure for better filters. Something to consider. Other units are best to increase the air exchange by using a separate air filtration system as an addition, not an air cleaner, a system designed for this application. Someone else said. On the filter slice told is you need these filters to save energy. Filters do not save energy. Low pressure is what saves energy. So you can actually just replace your filters before they are. If you replace as needed by pressure drops, needs to be replaced. Okay, we also have the option to modify the HVAC unit filter section by removing old filter tracks and installing more modern filter hardware that have lower initial pressure drop. Note, we need to keep within the designed fan curve or use a new motor with new designed fan curve. With the filters, we can add a HEPA even to the residential unit with no additional pressure drop to the system. We have been doing this for a year, and we also need to talk about the V-belt assist motors. These are the big energy users because most of techs install belts that do not meet any specification poorly tensioned belts increase energy use, lower the air exchange per hour, and show false readings. All right, so most of the comments, as we can see, they are around the pressure drop and how we need to replace filters if we need to achieve those low pressures in order to avoid higher energy on the HVAC system. Again, I see some new people have connected. If you have any comments, feel free to raise your hand and we are more than happy to hear you. We also had some comments in Spanish. I don't know if we have the person that wrote them here and they would like to explain them to us. Laudelino, I see you are connected, so if you mind trying to explain a little bit what you're
I'm
trying to
here,
say.
but I can see it. It's very small for me.
Yes, you wrote. It's quite dense. Can you give us some kind of a summary of what you wrote here instead of reading all of this and trying to translate it right now?
So tedious is because I'm in the phone and I can see what is in the
Oh, and you don't
well.
remember?
No,
Okay.
I'm trying, but I don't remember. Free cooling.
Yes, you're talking about something about free cooling and design of the systems.
Sí, te lo comento. Normalmente por el free cooling para evitar en gran medida el tema de tener que enfriar o calentar, sobre todo cuando sea una discoteca, un CPD, se puede utilizar para generar ahorro. Pero es que no me acuerdo lo que escribí.
Okay, so Laudelino is explaining a little bit what it's about, and this free cooling technology, which I'm not aware, it's used in places to avoid temperatures raising too high, if I'm not translating that too badly. And unfortunately, Laudelino right now does not remember, and he's on his phone, so he cannot read his exact comment.
Esto es importante. El tema de los lucernarios y la ventilación pasiva. Te lo comento un momento, ya sabes que mi inglés no es muy extraordinario, te lo comento. El problema que tienes aquí es no solo porque pongas detector de temperatura, a veces se genera un problema y es que tiras del aire inferior. Lo que haces es que si tú tienes calor acumulado en invierno, incluso puedes enfriar y necesitas más energía para calentar. Entonces lo que hay que hacer es impulsar hacia abajo, no abrir el lucernario.
I
En
see.
invierno, en verano sí que hay que abrirlo para que el calor se vaya.
Okay, so basically, Leonard is explaining a little bit the different environments that they need to adjust some of the settings of the system in order to accommodate it better. I don't want to go on those details right now. And actually, I received a comment now by Georgia is asking a little bit about the agenda as she has to drop out for another call. And Georgia, basically, we will go through the survey, and basically, I will ask the members to debate a little bit on the different aspects that we have inside the questions that we have developed, in order to get a little bit of a better understanding of ventilation. At GoEQS, we won't have, like, let's say, a standard for ventilation. We already have ASTRA and some other entities for that, but as a holistic approach for indoor air quality, we also have to understand some of the means that we have to go through in order to achieve good indoor air quality. I hope my my answer helps you. Okay. Now, in a different question, I asked the participant, how does the presence of gas contaminant like carbon dioxide or VOCs affect the required air exchange per hour? And some of the comments say that VOC affect a lot, especially public buildings. There is a high concentration of TVOCs when analyzed with modern indoor air quality monitor equipment because they are all designed for buildings. Another comment: to correctly calculate the reduction of dilution of VOCs, they must not be known accurately by chromatography and laboratory, at least to rule out dangerous concentrations of carcinogenic VOCs and carcinogenic, yes, the same thing twice. CO2 is not a real problem in indoor environments in the absence of air pollutants as long as the concentration does not exceed up to 5,000 parts per million. Up to 8,000 humans are not affected by CO2, and up to 40,000 CO2 is not lethal. Some comments that we received. As I see it only by allowing these unwanted gases products in or to build up on the breathing zone. Again, I remind you that if you see your comment and you would like to add on it, feel free to raise your hand, please. There are two different types of pollution in buildings that we allow in through the fresh air requirement, and what we allow to be produced in the breathing zones. When we look at the EPA NAQS and the OSHA IAQA table, we should not allow any of these products, if they can be filtered, in our fresh air requirements. In a non-filtered product is above the limit of exposure, then the fresh air needs to be reduced or turned off. Someone else comment here. Another comment: due to overwhelming of gases products, each building needs to know what needs to be monitored and controlled per the local area of the building location. We cannot use zip codes examples since the building next door, may have licensed emissions that affect the next door building fresh air requirement. If gas contaminant concentrate increase, then you should increase the air exchange rates. Well, this is a little bit tricky, as we need to know where the gases are coming from. Because now, if VOCs are coming from outdoors, by increasing the ventilation rates, then we may introduce more VOCs inside the building, or some other pollutants like nitrogen dioxide, etc. And I hope, hopefully, everyone agrees on that. I would like to hear your opinion. I really like to hear your opinion today. Another comment says that certain gas pollutants, such as volatile organic compounds or radon, tend to be found in much higher concentration indoors than outdoors. This makes dilution the primary removal strategy, meaning the introduction of the sufficient fresh air, outdoor air, and the extraction of stale indoor air. If the potential concentration of these pollutants are known, such in the case of radon, which infiltrates from the ground, it may be necessary to increase the air exchange per hour to reduce the risk in high radon concentration. For this reason, studying pollution sources beyond general air regulation is of vital importance, and this aligns perfectly with what I said, right? We need to know where the pollutants are coming from. Another comment in Spanish. La verdad es que es bastante, pero no again, Laudelino is explaining about VOCs, and I think that his comment is very similar of previous comments about VOCs versus CO2. Another comment: higher concentration levels demand more air exchange to dilute and remove excess pollutants. CO2 and VOC should affect the air exchange that may be modulated dynamically. For example, TVOC usually is 70 to 90% in the absence of scientific studies support this. And finally, CO2 sensors are a proxy for the efficient ventilation. So I will separate that out from the question, as in that role is directly impacts the exchange rates. VOCs are always present and should impact the ventilation rate, but to what degree is difficult to qualify due to their presence. Amount varies affects, if known, on air quality. When discussing air exchange, it is needed to address VOCs with this unknown in mind. Someone else commented. No comments from anyone. Let's see. Like Juan, you are in this industry as well of ventilation. Do you have any comments around what we have read so far?
Hi, hello. Well, yes, actually, I think I mean, in my opinion, I'm more aligned to ASHRAE standards and into the brand new ventilation standards we have in Europe. So I tend to sorry for my English. I will try to do my best. I tend to observe that it's mixed the understanding of CO2 with pathogens, you know. So I would like to signal the fact of CO2 or carbon monoxide not being pathogens at all. And this is something that at least all the communities based on the American standards and also the European countries is something that is widely and broadly accepted. So the fact is, if we observe these ventilation standards, they say that you might respect at least 4 liters per second just to dilute CO2 and carbon monoxide, and they invite you to actually reduce the real pathogens, which are particulate matter, COVs, bacteria, mold, spores, and others actually.
Mm-hmm.
So that's exactly what I was explaining in the comment where I remind people that CO2 is not lethal until up to the 40,000 ppms, and you have no affection in absence of pathogens of pathogens is not affecting human beings up to 8,000 CO2s. Yeah, of course, someone will come to me and say, "Hey, there's a scientific study saying whatever," and probably it's okay. But if you study deeper that study, they are not considered the fact of having no pathogens on real pathogens. I mean, these 5 kind of pathogens: particulate matter, COVs, mold, spores, and bacteria, and others, right? So I wouldn't mix that. In my opinion, it's pretty easy just to observe when you are calculating ventilation, the amount of pressure you're needing just to dilute CO2 and carbon monoxide.
Mm-hmm.
From the ventilations you are really needing to achieve an indoor air quality index, which would be probably mandatory depending on if we are talking about an office building or hospitals or commercial buildings or whatever. So in our experience at Praditiv, yeah, we can tell you that for real, and it's not a problem to reduce ventilation up to an 80%, based on the airflows people is used to use in their calculations. So saving huge amounts of energy based on the ventilation or on the AHU ventilation fans, and of course by the reduction of the thermal load of the ventilation thermal load. And even when you are reducing those 80% of the previous airflows,
Mhm.
you will be keeping CO2 levels down. Why? Well, basically, in average, an adult human being will exhale 0.4 liters per second of CO2, no more than that. And the European and the American standard says that you have to keep at least 4 liters per second, which is a huge amount of fresh air considering the exhalation of every single human being inside. So yeah, it's time, at least for us, I guess. This is our position. It's time to break that barrier based on how things were done till 2019 in America or 2008 in Europe, and not considering anymore that high levels of CO2 could be harmful for people. Just in case you are measuring indoor air quality and you know exactly what you're doing, you don't have to freak out. And why I'm saying that? Because, well, actually, if you get used to the OSHA's the prevention risk standards in the United States, or if you get related to the prevention risk standards in Europe, you will find out that the professional limits exposure to CO2 in 8 hours is like 3,500 ppm in Europe and 5,000 ppm in the United States, and nobody complains about that. And when you measure your indoor air quality, you can even you could even have an ISO 6 for surgery clean rooms, and that's nothing to be concerned about that.
Right, and we have discussed those things also during the carbon dioxide session at the beginning of the week. Thank you, Juan. I don't know if someone else would like to add something else. I can continue. Then I asked members about if there are any advantages in ventilation technology that can help optimize those air exchanges and improve indoor air quality. Again, we have comments that they are talking about different solutions, like, for example, the use of strictly physical, not chemical or physico-chemical air purification systems. And they give us an example, or non-dielectric electrostatic systems for the trapping of the organic and inorganic particles and the degradation of VOCs, as long as the potential differences do not exceed 13.69 of electrovolts. I would assume this is first ionization energy of oxygen. There are too many to list. I hate listing them in print. People think I am recommending a product and they use it in application. I will not use it in. Another example is a bipolar. If it's certified by the 241, if your returns are in the ceilings, you need to end up with a very high large particle count mass at lower levels. Short people and kids will breathing in these large particles. They comment. Again, bipolar was mentioned. Use both positive and negative ions that need to be controlled, that bring submicron particles together. They gain mass, weight, and they fall to the ground with neutral charge. They do not stick to equipment that has a charge. These particles will build up in occupied space at floor level. Is not controlled. Yes, we can control them. I think another comment says using air purifiers. I was assuming they are talking about those standalone units that we can use indoors. Same answer of the first question. well, we don't remember now. And someone is talking about the ACH approach. And
Yeah, so Tios,
yes,
yeah,
please.
just 1 second. Yeah, but based on this part, actually, well, even when they're talking about ions or whatever, they're talking about actually about electrostatics. So the potential differential, the potential difference in between anode and cathode should be less than those 13.69 electron volts, which is actually the first ionization energy, the oxygen first ionization energy, right? And that's because just in case you achieve that, then you will be, even when they, well, I'll explain that later. Then you will be actuating over oxygen, making it to react and be reduced in chemistry to produce, how do you say that in English? Sorry, hydroxyl radicals, right? So that's completely forbidden under the European and under the American standards. And that's something to watch out, because out there's a lot of different brands calling their technologies with many different names, but there's not a lot of different technologies out there. There's just 4 different technologies to act over particles. So this is quite important because also in Europe and in United States, they both agree on on doing mandatory for these manufacturers to achieve or to accomplish with no sorry, have to think I have person in Spanish. In the no byproducts production and no ozone production, right? So the first one, the no byproducts, is something to really yeah to be it's something that really needs a closer look and a deeper look, because when they say no byproducts production, they should have to certify which byproducts actually they're not creating, because this is not just something for hydroxyl radicals. No, it's for every single oxygen radical, and there are plenty of them. Ozone, it's an oxygen radical as well as the hydroxyl radicals, but they have we have at least 13 oxygen radicals of concern. Most of them are carcinogens. Yeah, carcinogens. So if any technology produces those, then those radicals, those oxygen radicals cannot achieve anyway in any quantity the breathable area. I mean the indoor where human beings are breathing actually. So this is something that we definitely should work deeper, because there are a lot of different brands speaking about the good qualities of their product, and actually there are some out there in the market that accomplish with all the regulations and are pretty good, and actually they have a really noticeable results on managing particles. But most of them they don't even have an idea on how their product really works, and I'm talking about salesmen, right? Speaking to engineers about the capabilities of their technology, and they are not even able to explain exactly the basis on physics and chemistry of their own product. So we should. This is something for us, I guess, at Goa QS, this is a really strong point of interest.
Thank you. And we received a comment that they suggest, like, for example, as a solution to have demand control ventilation systems, like basically controlling the ventilation based of where it is needed according to some sensors and air quality monitors that we may have in place, right? Okay. Another comment was about ionization, which they distinguish it between soft and hard. And they claim, they are saying that basically soft ionization is like a good option to have inside buildings as it doesn't produce all those byproducts. Then smart ventilation, again, what we have mentioned, thanks to the technology of the air quality monitoring solutions that we have in the market right now. Use of combined high efficiency and low pressure drop filters, heat recovery ventilation with enthalpic cores. I have never heard of these expressions, of this terminology. If someone wants to explain to me what it is, I would love to hear more. Carbon filters are used dynamically or used of sensors to switch filters and the balance the ventilating systems. And then HEPA, activating carbon filters in the CMV, and recovery units for heat and air. Okay. I don't know if someone wants to add something more around bipolar, for example.
Yeah, just again, Sortidios, for instance, I don't know who wrote about these PCO technologies, which is PCO are basically, I'll say that, photocatalytic reactions, right? That's the term for PCO. So what these photocatalytic reactions create? Well, they are actually reacting. Probably the most extended technology is to react UV lights with titanium dioxide, sorry, just to produce hydroxyl radicals, which is what I said before, right? So depending on these electrostatics technologies, depending on the potential different the potential differential they are running on, they will be also creating well, actually the same substances. They are saying that the photocatalytic technologies creates, right? So it depends on this. I'm agree on. I don't know who wrote this in Spanish, and I'm agree with this guy, right? But we don't have here enough information about exactly which is the amount of energy they are using just to create or work.
And hard, right?
Yeah. So this term of soft or hard ionizations, these don't really exist. I mean, those are commercial terms. So
someone else shared a link here on the chat that it goes back to EPA from the US. And basically, they say a little bit the same thing that we are talking about right now.
Yeah.
Like, it can, but in many cases, the terminology that is used around different products, it can be challenging, and marketing in some cases overpowers the right abilities of product, right?
Yeah, correct. So we will speak about that list. We will have to do about based on the different brands, just to classify by the real technologies they're using under the brand. You know, the brands are correct, and it's really cool. But in order to be sure that we are achieving all the regulations and all the mandatory regulations we have on different countries. Yep, it's I guess it's urgent to classify these technologies by their physical or their chemical principles of actuation.
Or maybe a standard is needed around those products in order to be able to distinguish clearly of whether they are faithful to what they are claiming or not, right? Like,
Yeah, correct.
maybe we don't have something at the moment.
Correct.
Then another question that I asked participants was if they have a specific number around air exchange per hour in schools, particularly. We got a variety of numbers. I tried to summarize them. So basically we had between the majority of them, they agreed between 6 and 8. However, it is important to note that all participants gave an average number of 10 air exchange per hour in schools. I don't know if this is something achievable in buildings. Lula, you have raised your hand, please.
Hi, I was just saying that these inconsistencies with communication of efficiency and efficiency against overall product is something Belgium is trying to regulate as well. We have a legislation published in 2024, February 2024, which is a first draft of high efficiency air purification systems against viruses. And we are now opening it up. We are in the process of opening it up into different categories of efficiency and different pollutants as well to create a harmonized way of publishing these results and efficiency so that the consumers can read it. Right now, we're working in auto declaration system. So the fabricants, the industry needs to fill in a dossier with us, the federal government, which we then evaluate and make sure that everything is provided and that we will integrate into a label, and they can only use that label to communicate their efficiency against viruses and aerosol. So this is also in wake of the corona pandemic. So because there was a need for air purifiers and it was great, the market was swarmed with different types of products, that at least the people that were able to prove it, okay, only administer on an administrative level, that they could look for these types of systems on the market.
Thank you.
That's great. Sorry, Lula, it's available that standard your government has written just in order to.
It's not a standard. It's a law that we created ourselves based on on different things, but we determine different what's it called? Different demands that they need to adhere to in order to get this label. It's also available in English on our website normally. I can search the link and put it in the chat.
Yeah, that would be great. Thank you. Yeah. I would like to have a look.
And you can always contact me afterwards as well.
Sure, fantastic. Thank you.
And also, I don't know if you are aware, Lula and the rest of you, but I am part of a European project under the Coast Action, which is called Net for Clean Air. Basically, right now we are collecting information to find all of the products from portable to stationary to products that they are meant for the HVAC system in order to filter the air. So we are basically looking for all the purification and cleaning technologies around air quality, in order to create a database, a global database, and it's going to be eventually open for everyone, including the politicians, but also the end users like you and I, that we need maybe to get some kind of help choosing the right product for the right need inside the different buildings that we may have in presence.
Yeah, I think we have a lot of in-house knowledge on air purification systems because we started with this legislation during the corona pandemic,
Mhm.
and we've seen a lot of different. So I was part of the experts that evaluated these files.
Mhm.
So now I'm the senior expert on that field. So we saw a lot of different types of systems that passed through, a lot of different types of testing that was done. And so I can maybe definitely help you with a more general approach on that.
Oh, thank you. Perfect.
Great.
Someone has raised his hand. Laudolino?
Sorry, but my English is not so good, but please, I would like to see the information about what is doing in Belgium. I would like to have, if it is possible, a copy of this information about the system of clean air.
Yes, I think they have from me or from Lula, you mean?
From Lula is because I would like to see it.
I think Lula has shared a link right now on the chat.
Yes,
Because I'm in my phone and I can.
so the link is to our general website, which explains a little bit more about our initiatives, and it's available in Dutch, but French, German, and English. And then I'm looking at the link for our legislation. We also have it translated in English normally, and people can take a look at it.
Okay, so meanwhile, I will try to move a little bit forward because we only have 10 minutes. So in order to summarize a little bit this slide about the air exchange in schools, the greater the number, the better. Between 6 and 8 was the most common value, but the average among all was like 10 air exchange per hour in schools. I don't know what in different countries they follow standards and regulations around school air exchanges. If someone knows a little something more, please feel free to share this information. And then the next question is, in your experience, what is the percentage of smart buildings that can adjust air exchange based on occupancy level? It's hard to understand from here, but basically the majority of the people were agreed that like 10 to 20% of the buildings right now, they have those systems in place. Probably it's lower. I mean, in a global scale, I don't think we can achieve those numbers as the majority of the buildings are already old, and of course new buildings, it's easier for them to integrate those systems because they have already taking into account, you know, connectivities, energy, and all of those little details that those equipment need in order to operate inside buildings. And finally, one of the questions that I asked was, which ventilation standards do you currently follow, sorry, for your work, or maybe because you really like this kind of standard? ASHRAE, as an organization, it was like predominant. Then we also have some European standards for residential and non-residential buildings, alongside with ASHRAE 62.1. Someone else said, I try to maintain the building design specification. That's again for new buildings. Old buildings, they don't have any design specifications. ASHRAE again 62.1 and 62.2. ASHRAE, the newest ASHRAE, the 241, which for those of you that don't know, which I hardly think so, provides even more air inside buildings. Here in Spain, I think we have RITE, CTE, and some other European standards. Some people are also following some passive house standards. And finally, again, ASHRAE 62.1, and in general, ASHRAE was the predominant standard for ventilation. And those were some of the open comments people shared during the survey. Again, if you see a comment and you would like to say something more, feel free. Let me read them really quickly. According to your question about the maximum air exchange ratio for schools, the question is not correct because every building spec, volume, occupancy, and pollutants will be unique. Well, obviously, and the reason I ask this question is because as people are from different parts of the world, I would like to see if they have all of those different specifications when they recommend a number. The correct answer is 1. The exactly amount required once calculated, or based on the accepted occupants and the real outdoor and building, including material pollutants for the indoor air quality you want to achieve. The problem with variable speed drives and indoor air quality, the building owner will always pick energy saving or over indoor air quality. Performance, I know casinos in Las Vegas who run the system at 30 HTZ, I don't know what this term means, to save energy and filter replacement. Does anyone of the committee knows what HTZ means? No? This is where AI will help save energy for monitoring indoor air quality. If the indoor air quality reaches the set point, the AI, will reduce the air exchange rates to the reasonable level to save energy, if the monitoring says it's okay. At the same point, to increase the air exchange, if the indoor air quality monitoring says it's required. Oh, hertz. I see. Oh, okay, I didn't see the hertz. We don't use the T, right? When we say hertz. I have the speed. Okay. Thank you. Thank you, Sid. It also means you may be using the recommended MERV 13 filters, but if the filter or system is not sealed, you may never be able to reduce your air exchange rates due to your poor preventive maintenance practices. Demand control ventilation is a complex topic, mostly because of old strategies. GoAQS should propose much more modern approach based on advanced sensor readings, including CO2 PM, VOCs, and filtration modulation. I don't remember if we have any other comment. No. Okay. So this is what we learned from the survey and also from the comments people were able to share here today. Does anyone else would like to add something else before we close this session? No? Okay, perfect. Thank you all for coming. Following in 4 minutes, we have the filtration session.
Okay.
Hopefully I can see you there as well.
Thank you.
Thank you.
Thank you
Have a
very
great
much,
day.
Andreas.